Okay, so our major topic today, we're gonna do an in-class activity today. Tuesday. It was just a little in-class activity that we did.
Yeah.
This one.
Thank you.
Okay. All right, so we're gonna do an in-class activity today. Again, we're gonna be doing linear equations. So if you didn't understand that concept from Tuesday, this is what we're going to be going into. I think I did just kind of a brief rundown to linear equations. There's different forms. Now, I've only really talked about the first one, the one that we use for graphing, right? That's the one that's pretty much everyone kind of knows. It's slope-intercept form. It's the one that you probably use the most in Algebra 1. Slope-intercept form, if you're not familiar with it or you don't remember what we talked about on Tuesday, that's one where it's y equals mx plus b. X plus b. This is just a form that when it's written in that way, where y is by itself, there's no number in front of it, just y, and then there's a number x plus some number or minus some number, whatever it is, we can immediately take that and go draw it. Because it's in this form that it's telling me very important numbers. The two numbers that are actually important that it's showing you, this b number that's in the back, whatever this number is, it's positive or negative, doesn't matter, it's whatever that plus or minus sign is. This number is where you're going to hit the y-intercept. The y-axis, where it crosses the y-axis. So we can make up any number you want. So if I want to hit at negative 3.5, I'd put that number in the back. Then there's gonna have to be some number in front of x, and I'll have an equals y number. Okay, so that's that y-intercept. So it's wherever I'm going to hit, if it's in this form. If they're rearranged, if these are flip-flopped, we'll look at one of those later. You just rearrange it. You can do that. It doesn't affect anything. It's called the commutative property. It's one of the things we're going to discuss today. But that's your y-intercept. It's where you hit the y-axis. Now, the second item, the n in the front, that is your slope, this number. Now, what slope stands for, it's how the line is tilted. That's all it is. There's a line going through negative 3.5, 3.5, but it's tilted in some way. So what you have to do is look at that number that's in front of x, and you always want to make it a fraction if it's not 1. So if it's a whole number, put a 1 on the bottom. If it's a decimal, put a 1 on the bottom. If it's a fraction, leave it. Okay? So let me just make up a number here. Let's go with like 2 over 3. Just kind of make up a number here. I can go draw this now, just by knowing those two numbers. Now, there's different ways of drawing it. I think this is the easiest way. I'll show you a different way in case that fails you. If you don't remember, I'll show you a different method you could do. But let's start with this idea. So I'm going to start at negative 3.5. That's where I'm going to hit the y-axis. So negative 3.5 is down here. Notice I went down 3.5. Okay, so that's where I'm going to hit the y-axis. Y-axis is that line going up and down. Then from there, this slope comes into play. The 2/3 is rise and run. Now, if it was negative, it would be falling and run. But now, in my case, it's a positive fraction, so I'm going to rise and go to the right. So I'm going to rise 2, run 3. So that means you're going up 2 from that dot that you just started, and then go over 3, and I always go to the right. That's just how I always think of it. So rise 2 from there. So notice how I stayed in the middle, because I was at 3.5. So I have to stay at the half markers as I go up. I'm going up 1 full mark. So up 1, up 2, and then go over 3. 1, 2, 3. And this is where that next dot would be. Does that make sense? And then I would do the same thing. I would plug in, I would rise 2 again, 1, 2, and then run 3, 1, 2, 3. Notice when I run, when you actually jump, that's the count. You don't count the first dot that you're at. Don't count this as 1. You have to actually make the leaps when you count. So that's the trick. And you can keep going. Now, if you didn't want to do that, and maybe you ran out of space, you can make these exactly the opposite. You could drop and go back to the left. So just go the exact opposite. Drop 2, go back 3, and you'd still land on the same line. That's what we're looking at today. Can you draw them very, very quickly? Do you know where to start? Do you know where to go? That type of thing. Questions with the first type. Okay, we're going to come back to this because I want to show you a different method of drawing that in case you just forget. You're like, God, I don't remember which one's slope and which one's the y-intercept, or maybe you just don't remember it at all. Like we get back to that, when we get to the test eventually, you're like, I don't remember how to draw this. There is a fail-safe way that works for every equation. Doesn't matter if it's in this form or another form, there's always a different method. So we'll look at that. But now let's look at the other forms. I do want to just intro these today. This is not the majority of your homework. I just want you to see them because that's the stuff we're going to be doing on tomorrow for Friday. So the other forms, one of them is called point slope. Point slope form is the other form that when I was in school was used a lot. It's used a lot in calculus and like upper level math classes in college. My professors always use this form, but here it is. I'll write it the way that they always did. Yes, those are little ones. They're not commas. They're like tiny little subscript ones. This is the form. M is still slope, so that's really like it's pretty easy to see that. So still the same M. It's still your slope. It's outside of that parenthesis. It could be a fraction. It could be a whole number. It could be a negative number. I don't care. You just make it a fraction, so you know kind of where to tilt the line, how to draw it. Now the x1 and y1. Because I know those seem weird. Like you have two x's and you have two y's. It's really weird. But they denoted one of them as x1 and y1. The x1 and y1. Okay, I don't want to make a comma between there. The x1 and y1, that's the dot you have to start at. This is the starting point. That's the idea. So notice that in the formula, you'll always subtract that coordinate, whatever it is, whatever starting point you have. Now, why this is kind of a go-to method in college, typically in college, they try to give you like real story-based problems. Well, maybe you have, you've been plotting your data for your business, and you know kind of one of your data sets, one of your point sets on the data that you're kind of plotting, that could be your starting point on this formula. You can just plug your starting point into the formula, and now you're already off and you have a formula that represents your data. Then you just have to look at the slope of your line. How is your line tilted? Is it rising? Is it falling? What is it doing? Then you can use that formula to predict what will happen down the road. So it's a starting point. So I'll give you an example here. Let's say the formula is like y minus 3. Let's go 1/5 x plus, I don't know, let's go 7. Something like that, right? So just looking at this idea, my slope here, this is 1/5. That's my slope. So that's the rise and run, going up and over, right? And then the coordinate, what is my starting dot? What number is with the x? 7. It's always the opposite of that number. So whatever this number is, because it's technically supposed to be subtracting whatever that number is. So I don't have subtraction, so it's the opposite of whatever this number is. So the opposite of that number is -7. And that makes sense. If it was subtracting a -7, it'd be a +7 in there. Okay? And then over here, what's the opposite of a -3? +3, yep. And that makes sense. So you're subtracting whatever your answer is. So subtracting whatever the answer is. So that's why this is your starting point. It's always the opposite in that coordinate. And that makes sense for how this works. So if I was drawing this, I would start at, what is that, -7, 3? So -7 over 3 up. 1, 2, 3, 4, 5, 6, 7, up 3. All right, so there's my starting dot. There's my starting point for my data set. Maybe that was 7 months ago, and you had 3 sales, let's say. That was 7 months ago, you had 3 sales. And now you're trying to plot where are the rest of your sales going. So, and you kind of looked at the slope, and you said, okay, the slope is 1/5, so I'm rising 1, running 5. So rise 1, run 5. 1, 2, 3, 4, 5. So here's my next data point. So I went up 1 over 5. And then I do it again. Up 1 over 5. 1, 2, 3, 4, 5. And rise 1, 1, 2, 3, 4, 5. So it's taking you quite a bit of time, but you're making slow progress. It is going up. You're making more sales, every couple months. It's not a big jump, but you are making sales. You are going up. So you can predict what would happen, 20, 30 months down the road. How many sales did you have? How much product do you need? That's why these are useful. You can, you took your first data set and you kind of knew the general direction you were going. Well, then that tells you kind of how to predict what your formula is. All right, questions with that form? All right, those are the two basic ones, like the two main types. Those are the ones that, in college, they're the ones that most people want to draw. because you know the starting point, you know slope, and go from there. There's other forms. There's actually 3 others. I'm just going to list them out here. The other forms are standard form. This is a form that they use a lot in Algebra 2. We will see standard form this year. You will see it. It'll come up in when we do, I think it's quads. They come up when we do the quadrilaterals in chapter 6, 5. I think it's chapter 5. So that'll come up, I think that's usually about February time frame. We'll see standard form a lot, and you'll see kind of how to do it. Then, and again, that form looks like this. So the A, B, and C are just numbers. They're digits. They can be negatives. They can be decimals, whatever. Typically, in most textbooks say that in standard form, you can't have decimals for A or B or C. They can't be, A can't be negative. It doesn't really matter as long as they're digits. You can always change them. You can manipulate the formula. But that's standard form. I'm not going to show that today. The other forms are general. There's general form. General form is basically the same as that one. It looks almost the same, but they have a 0 on the one side. So basically what it is, they drug C over, and it became a negative C, basically, and so I just changed it to a different letter. So it has 0. You'll see this a lot when we do factoring in Algebra 2 or pre-calc or calculus. That's a go-to method. We always like to have 0 on one side so you can actually solve. And then the last one is, it's not really another form, it's special cases. These are ones we'll probably look at more and more. There's special cases of equations where when you draw them, they're really easy to draw. It's when you have a vertical line straight up and down, or you have a horizontal line where it's straight across. Now, why those are special cases, they have a very weird looking formula compared to the others. All the others have 2 variables, but when you go to special cases, they only have 1 variable, like just an X or just a Y. So those are the ones we're going to look at tonight. But those, again, I'm going to save those for later. The goal today is to really focus on like these forms so that you know how to draw them. Okay. I think pretty much today I'm gonna really just kind of hammer this one. This is like the go-to method for Algebra 1. Eventually we'll kind of mold into the other ones. Okay, we ready to go? Okay, so let's talk about that one case that I talked about earlier. I don't even know what the problem was. What did I give you? It was y equals 2/3 x minus 3.5. Is that the first one that we did? Okay. There's another way to do this problem. If you don't, let's say you don't remember that you have a y-intercept and you have slope. Let's say you just, man, I don't remember what to do. I don't know which number is which. I don't know where to draw it. Here's a method you could do. I don't recommend it, but it's a fail-safe. It works every time. You could just plug in numbers for your x's. Plug in 2 or 3 of them. Any number you want. I'd plug in 0, plug in 1, plug in 2. Just plug in really small numbers. And see what number it gives you on your calculator. That's a fail-safe. It will draw the right line. It will draw the same line every single time. It's just one of those things, like it's nice to know that you always have a backup in case something's failing you and you can't do it. Okay? Mr. Wardier. I do. Oh, yeah, perfect. Yep, bye. Your call.
Me?
Yeah, have your glasses. So, all right. So I have 3 numbers, right? I always pick 3 just as a fail-safe. What you do is you just plug it in and solve. So if you have a calculator in front of you, it's really easy. So, for instance, if I'm going to plug in this 0 first, these are your x numbers, and you pick any numbers you want. I just pick 0, 1, 2. I always pick small numbers. I don't care what numbers you pick. You can pick negative numbers for all I care. But I'm going to plug in 0 first. So I'm going to plug it right into the x location. And on your calculator, you just type this in, and you figure out what y numbers it can give you. So if I plug in 0, what's 0 times 2/3? 0. And then I'm going to subtract 3.5, which is negative 3.5. So you just go draw that coordinate, right? So this number I plugged in 0. It spit out 3.5 on my calculator. So that number is the coordinate that I draw. I'm going 0 right and left, down 3.5. 0 right and left, down 3.5. Well, duh, that was my y-intercept. Makes sense. I mean, it's drawing on the same exact dot that I needed it to. So now, what's the next number I should plug in? Plug in a 1. Okay, so let's plug in a 1 now. So I always go to my next number. So I'm going to plug in a 1 and see what it spits out. So now, how you do this? You take 1 times the top. This is how you do it normally. Take 1 times the top, and then that's 2. And then you divide by the 3. That's how you multiply numbers together. So, especially whole numbers. 1 times the top is 2, divide by 3. On your calculator, I believe it spits out 0.6 repeating. Correct? It tells you when you take 1 times 2 divided by 3. And then we have to take 0.6 repeating and subtract 3.5. So, what do we get? If somebody has a calculator, take 0.6 repeating, subtract 3.5. Say it again?
Negative 2.83 repeating.
Okay, so it's almost negative 3-ish. So negative 2.8. So the next one, drawing this next dot, this coordinate is 1 over negative 2.8 down. So 1 over negative 2.8 down, it's about right there. Kind of ballparking it. Okay, does that make sense what I'm doing? If I'm just typing in the calculator, you don't even have to think about it. A lot of you have like fraction buttons on your calculator, like mine has a little ABC button. You type in the 2 ABC 3, it gives you the 2/3 on your calculator screen. Then you just put in parentheses the number 1, subtract 3.5. It'll spit out this number. Now, the next number I'd plug in 2, and I do the same exact thing. So the next number I plugged in is 2. So 2 times the top is 4 divided by 3. 4 divided by 3 is 1.3 repeating. Then I would take 1.3 and subtract 3.5. So on a calculator, what do we get?
Negative 2.16 repeating.
Negative 2.16. Okay, so over 2 down 2.16, kind of roughly right about there. And then when I draw, there's my line. 3 dot kind of is a fail safe. It kind of gives you the general direction. Again, you're just plugging one number in at a time. So whatever numbers you pick, I don't care if you pick 20 here. Cool, you just have to go draw it though. So whatever numbers you plug in, that's your X number and that's your Y number, and you just go plot it. Why I pick 3? It makes sure that when you plot your 3 dots, are they in a straight line with each other? Again, it's really hard to draw decimals, so you just kind of have to get in the general area. But it's just kind of a fail-safe. So it will get you the same line as the one I did earlier. Okay, questions? All right. Now, if your equations don't look like that form, let's say they don't look like this, and you can't see, okay, here's my y-intercept, here's my slope. You could always rearrange an equation to that, or trust your table to it. That's another fail-safe. So what I mean by rearranging. So give me any numbers you want. Say a number.
10.
10, I heard 7 and 2. Okay. 10x plus 7y equals 2. Let's say that's my number, right? I can rearrange this thing. I could plug in numbers, see if it works. I don't want to do that. I could rearrange this so it looks like that one. Then I can go draw it. So whatever random crazy equation I give you, that's, by the way, that's in standard form. If I just rearrange this thing, I can get it to look like this. So the goal is to get y by itself. So when you move things across the equal sign, they become negatives. So anytime it moves across the equal sign. You can switch things over here, it doesn't make a difference. But when it moves across the equal sign, that's when you have to add or subtract it technically to both sides. So if I move this 10x over, because again, I want to get the y by itself. So if I move the 10x, what happens to the 10x? It becomes negative. I'll put it right here, I'll put it in the front. I just put the x and then the number. The 2 is positive, so I just left it back there. The 10 became negative because it went across the equal sign. Now, how do I get rid of the 7? not subtract, divide. The reason why I'm thinking multiplying on y, so you do have to actually divide it. So I'll divide everything by 7. That's how you draw this. That's how you rearrange the equation. So if there's any x, you move it over to the other side. Sometimes you don't even have to do that. Maybe the x is already over there, but you have to get rid of a number in front of y. So divide by that number. Now this thing that you're looking at is in the right form. This is my y-intercept, whatever that number is on the calculator, 2 divided by 7. That's where I start my y-axis. This is my slope. And I draw it from there. It's in the right form. It's y by itself equals mx plus b. Now, what is 2 divided by 7?
0.285.
285. All right, so that's this number. It's 2 divided by 7 on the calculator. That's my starting point. That's my y-intercept, right? So 0.2875. 0.2875. That's about right there. It's not quite half. It's really small. It's a number on the y-axis. And now my slope is telling me to drop 10, run 7. So this is rise and run. So I'm going to drop 10, run 7 from that dot. So drop 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I was dropping 10, staying in kind of that same location, and then going over 7 to the right. I always go to the right. So it's over 1, 2, 3, 4, 5, 6, 7. There's my next dot. And now I can draw what my line is doing. Maybe you ran out of space and you couldn't go that direction. Fine, then I just do the exact opposite. I would rise 10 and go back 7 the other direction. So from here, rise 10, run back 7, and sure enough, you'd hit that same line just over here. Questions with what I'm going to have you do today on this elective? I'm going to have you draw. You have 3 problems. 3 that you have to draw today. 3, that's it. Okay? All right, I'm going to turn you loose on it. Let's see how you do. This is the only thing today. We're not even going to introduce what we're doing tomorrow because I already did. So, put on my little mask and we'll get started. Two of them are already ready to go. You can just go draw them right away. But one you have to rearrange. Now, if you don't like to rearrange, you could always do the little table idea that I did. I just recommend rearranging it. It's a lot easier. Put your name on it. This is due before you walk out this door. You have about 16 minutes to kind of work on this thing. Again, parent-teacher conferences tonight. I believe that they start at 4:30, go to 8. So if your parents want to come in, always recommend it.
This one,
Yes.
he tells me when that passes.
I didn't realize what it was.